Geometry, Unit 4, Section 4, angle, side, angle, and side, 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 triangle congruence. So last video, last class, we talked about side, angle, side, how we know that if two triangles are congruent, that means that there's three pairs of congruent angles, three pairs of congruent sides, a total of 6 pairs of congruent parts. But to prove triangles are congruent, you don't need to prove all 6 pairs are congruent. You can get away with just 3 pairs. And that is sufficient enough evidence to prove the whole triangle is congruent to the whole triangle. And so last time it was in a side angle side relationship. It was 2 pairs of congruent sides and the angle connecting those 2 pairs, and that was side angle side. This first example I want to show you is angle side angle. And so what you see in this example here is that this angle with the double arcs is congruent, and this angle with the single arcs is congruent. And so the side between them is congruent. So this is your angle side angle here, and that corresponds to this angle, same length as this side, and this angle. So that angle side angle is congruent to that angle side angle. And if you have an angle measurement, 2 angle measurements, and the side between them, there's only one way to form a triangle with that. And that's basically, I don't know what the lengths of these other 2 sides are. I only know the length of this side. Well, if you extend this line here and extend this line here, that's going to form the triangle. There's no other way to do that. And the same thing here. I extend these lines. I'm creating the same triangle. And if you take your ruler out and measure, you'll see that this is congruent to this, and this is congruent to this, for this point here. And if you take your protractor, you can measure this angle, and you'll see that it is the same as this angle. So if you know that 2 angles are congruent, the side between them is congruent, then there's only one way to make a triangle out of that. So that means the triangles themselves are congruent, just like the side angle side relationship. So let's see a quick little proof where this would come up. So half of this proof is done for you because just to save time in the video, obviously the proof's in class, so you have to fill in the statements. You have your statements already there. I'm covering them up right now just so I could talk about them one at a time. But, this way I'll fill in these reasons here, but what I'm really trying to get across is how you would recognize an angle side angle versus, say, side angle side, like we did yesterday. So trying to prove this triangle is congruent to this triangle, we see that there. The first thing I'm given is that AB is parallel to ED. And so that's the first piece of given information right there. Whoops, I didn't want to erase all that. Let me just erase that top part. AB is congruent, AB is parallel to ED. So what does that do for us? Well, keep in mind that almost everything that you're given is leading to some sort of congruency relationship. And if you remember from when we last worked with parallel lines, if I jump all the way back to our cheat sheet, we do have 2 things here that come up with parallel lines. The alternate interior and the corresponding angles of parallel lines are congruent. So that's really what happens. Anytime you're given parallel lines, it's one of those 2 relationships. So how do I know if it's alternate interior or corresponding? Well, if you remember when we did that unit, you could look for a pattern that if you see a Z pattern, so if I highlight my parallel lines, there's only one line that touches both of them. Like this line doesn't touch both and this one doesn't touch both, but this does. And when I see that Z pattern, that's the alternate interior pattern. It happens a lot whenever you see 2 triangles like this that look like a 180 rotation of each other. That's what causes a lot of alternate interiors. So if you see parallel and you see the 180 rotation, you see that Z pattern, that means we're really trying to hint at alternate interior angles. And those alternate interior angles in this case would be angle A and angle D. So then what we can say is that angle A is congruent to angle D because alternate interior angles of parallel lines are congruent. Proofs are really difficult in the beginning, but as you do them more and more, they become much easier because the same thing happens every time. Every time we're given parallel, we're going to get either alternate interior or corresponding. Every time we're given perpendicular, we're going to get right angles. Every time this happens, the same thing happens. Every time it's very cause and effect. So once you get used to when this happens, it just keeps happening. And you get much more used to it. So that's our first angle congruence here, and it's an angle congruence. So I'll put an A over here. The next given was the perpendicular given. This is perpendicular to this is perpendicular to this. It's okay to group those together because they're the same type of given. And what do we get from that? Well, we know perpendicular, if these lines are perpendicular, they form a right angle. And if these lines are perpendicular, they form a right angle. So that means that angle E and angle B are right angles because perpendicular lines form right angles. Oops. Perpendicular lines form right angles. And if they're both right angles, then they are congruent because all right angles are congruent. There's some things that when we're given, we can jump right to a congruence. Like when we're given parallel, we could jump right to an angle congruence. But when we're given perpendicular, it takes 2 steps to get to the angle congruence. And so that's another angle congruence right there. All right angles are congruent. So we have this angle is congruent to this angle. These angles are congruent. These angles are congruent. So we have 2 pairs of angle congruences. Next, we're given AB is congruent to ED. AB is congruent to ED. And what do you know about AB and ED? They are corresponding sides of the triangles. So that's just a gift right there. That's a side congruence. You don't need to do anything with it. Sometimes you're going to be given one, or usually not more than one, but sometimes you'll be given one of the congruencies you need. Like I said, we're always looking for 3 pairs of congruencies. Sometimes you're given one of them. So that's just a gift. You just take it and move on. And so that is enough. We have 3 pairs. And just look at one triangle for a second. We have an angle here, a side here, and an angle here. Therefore, the triangles are congruent because the angle side angle of one triangle is congruent to an angle side and an angle of another triangle. And so angle side angle occurs when the side between 2 angles is congruent. Side angle side from yesterday, that occurs when the angles between 2 sides are congruent. So there's your angle side angle example. I also want to cover side 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 today. Now I know you're working on a piece of paper and you can't do what I'm about to do here, but I want to show you that if I have 3 lengths, like this is a fixed length, this is a fixed length, and this is the fixed length, there's only one way to make a triangle out of this. That's the only way for me to make a triangle out of those 3 sides. Like if you were to cut a piece of wood to this length, like to say 5 and 7 and 15, well, there's only one angle you can make by connecting those. And these are the same 3 lengths over here, but they're not, structured the same way. And let's see this. I can move this one over to here. This one I'm going to have to maybe turn a little bit. I don't want to change its length by turning it, but you can see that this is the same length as that. And so this length corresponds to this length, same length, and this is the same length as this length, and this is the same length as this length. These 2 triangles are congruent. You can use your protractor and you'll see that this angle is congruent to this angle, and this one's congruent to this one, and this one is congruent to this one. There's only one way to do that. So you can prove 2 triangles are congruent without proving any angle congruencies at all, if you could just prove that all 3 pairs of sides are congruent. So let me show you a quick little example of that. All right, so we got D is the midpoint of AC. So that's going to give us these 2 sides congruent, right? We know what midpoints do. So here's our midpoint, and that's going to give us AD and DC because a midpoint splits a segment into 2 congruent segments. All right, and then our next given is that AB is congruent to BC. AB is congruent to BC, and that's just a side congruency right there. So this was a side congruency we got from a midpoint. This was a given side congruency to us. And the last one, what do we know? BD is in common. Both triangles have side BD, so that is our 3rd side congruency through the reflexive property. and that is your third side congruence. So that means that the triangles are congruent because the side of one triangle is congruent to the side of the other triangle. And so we have angle, side, angle. Yesterday we saw side, angle, side, and now we see side, side, side. So based on the given information, find your three pairs of congruencies and then look at the triangle. Do you have two sides and the angle between? Do you have two angles, the side between? Or do you have all three sides correspond to all three sides of that one? So there's a couple others. And we do have two more, which we're going to see in the next one. See ya.